right, good afternoon. Welcome everyone in the room to our friends online. My name is Garrick Ng. I am the program lead for Kite Creates. We're a program here at Kite that's all about bringing the creative community, the design community in to jam and mix with our research and our health tech kind of venture community here at Kite. This is the next in our series of Kite Creates events. As you can see, if you've come to our events before, it's a special one. I'm joined by a lot of friends. We'll do introductions later to our friends from TriMech. As you can see, we even have a stage here. It's going to be a very hands-on, interactive presentation and demonstration, really zeroing in on the role of design, on prototyping and product development in both health, but just generally when it comes to spinning out design products. So I know you're going to get a lot out of this event. We're going to get into introductions later. A few housekeeping notes that I know I am tasked with, and already I'm missing my clicker. I'm going to advance one. Just acknowledging that this event is taking place on the traditional territory of the Mississaugas of the Credit First Nation and other Indigenous peoples who have lived here over time. We're grateful to share this land as treaty people who learn, work, and live in the community with each other. Noting here, and we'll have this up at various stages, we're going to be pretty casual, have a roving mic, but also encouraging folks, definitely on, if you're online or prefer, get your QR up here and phones scanning. We'll have an open Menti, and we'll do our best to incorporate as many of the questions that come out of this, and in person as well. Couple acknowledgements before we introduce our formal guests, all key team members, head honchos at TriMech. I want to acknowledge a very special person. They're all special, but a very special person, Michelle Sanchez, who we have history with and was part of kind of conceiving this early event, has invited some friends. I want to acknowledge from our friends at George Brown College, Professor Val Amon, and the team from the Fashion Technology Exploration Program, if I got that right. So thank you for attending. Hope you get lots out of this. Please ask us them hard questions, because we prep them that there'd be a very advanced audience here. Quick poll, like who here and don't be shy, considers yourself a product designer? Show of hands. Who's I see a few. That's where the challenging questions that come from. Who is working on something in the health or health tech space? Okay, a few. Good stuff. All right. So it's going to be, as you could see, a pretty engaged crowd. So why don't we turn it over now? Next slide. Before I give context to TriMech, also we acknowledge the only reason we're able to offer these events free and open access is because of the generosity of our supporters. So FedDev Ontario, the City of Toronto, acknowledge them as key partners. And of course, TriMech, who I think I will save the introductions for when you organically get on stage. A wonderful Toronto-based with tentacles outside of Toronto. Great story. Industrial design firm that's been so generous in kind of working with us to conceive a session that's rooted, in this case, on bathrooms. I don't know if we have our very own Dr. Allison Novak. Allison, if you're here, I will acknowledge that it was her contribution in some of the work that Kite is doing around bathroom safety and specifically around like the design of safety guidelines, which is, if and when we can talk more about Kite, one of the areas that we index quite heavily on, and specific to even grab bar design. So we thought, let's make this real. Let's tie it to some of the research and the product testing that takes place right here in our labs. So with that, why don't I kick it off? I'm not sure who is going to be first to remark, but Lena, Paul, Rob from our team at TriMech, and then Michelle and I will fade in the background. So big round of applause to welcome our guests. Thank you.
Hey guys, thank you so much for coming today. On behalf of Lena, Rob, and I, we're extremely grateful to be here. We're super excited to share our design process with you all. So I'll do a couple intros. My name's Paul. I've been at TriMech for about 10 years now in industrial design. And we have, with over 12 years experience, our lead designer, Rob, and our senior project manager, Lena. So our job's pretty cool. Every day we get to shape new product ideas from early concept all the way through to mass production, with a main focus on balancing style, performance, and ease of manufacturing. In this talk, we will guide you through a step-by-step process and show you how good design can help you guys with your development. To illustrate this, as Garrick's kind of already mentioned, we're focused on the redesign of a product that aligns with the research here at Kite, the bathroom grab bar. So looking at our design process, we break it up into kind of 3 important steps. The journey will begin with in-depth research, followed by concept generation in 3D CAD. We'll then turn these designs into proof of concept prototypes where we uncover what works, what doesn't work. And then our final stage, the fun stuff, optimizing design for manufacturing, looking for trusted vendors, and starting to plan your logistics to get into market. So we'll cover all that today. So now that we have this proven strategy in place, we can start planning to transform your vision to a market-ready design. So now, without further ado, Lena's going to kick us off with how to build that solid foundation.
Thanks, Paul. Can everyone hear me? Yeah, good. So let's get started with part 1, building a strong foundation and creating products that resonate. And to kick things off for you, we have a bit of a tongue-in-cheek cartoon here on the slide. But it illustrates a very real problem, one that products in your day-to-day lives that you might come across don't always meet our needs or expectations. So part of the talk here today is to explore how do we avoid that? How do we build that strong foundation to create truly meaningful products? And the first step with that is asking lots of questions. So whatever product you're developing, it likely exists across a wide variety of areas. So the first step is to identify what are those areas and what are the factors within those that might influence the success of your product. One of the major areas to start with will always be your end user. And for our bathroom grab bar, the end user will likely be interested in things such as, well, first of all, does it do what I need it to do? Does it provide support? Then it's probably going to have questions such as, how much does it cost? Does it look good in my bathroom? After the user, one of the key influences of design direction is the environment. In terms of the bathroom grab bar, there might be questions such as, well, does it resist moisture and chemical cleaner successfully? Additionally, what substrate are we mounting to? After users and environment, they're kind of like the big influencers of driving product design decisions. But there are other areas that might not be as obvious at the outset. For example, bathroom grab bars are typically retailed, so maybe at your Home Depot or through Amazon. Somewhere within that sphere, there's going to be a person or maybe a group of individuals that are going to be looking at your product and making a decision as to whether or not they want to carry it within their assortment. And the questions that they ask are going to be quite different. You know, they might want to know things such as, well, how much shelf space does it take up? What's the warranty policy? How does the price point of your product compare to others that are already on the market? And lastly, for a product stemming from a more medical realm, regulatory considerations will also be a big factor. So how does it adhere to existing standards? How is it cost effective? So after working through all the questions and noting down all your thoughts, you're probably going to have a pretty lengthy list of ideas for what your product might be based around. And the next step is to start documenting and organizing your thoughts. So there's several methods for doing this. Some common techniques are the product requirements document and traceability matrix. There's others, but those are some common ones. But the main goal in the reason for making sure that documentation exists is that you create a clear communication channel for what the requirements are for your product across all of the various people that might be involved along the product development process. So, you know, if you're talking to your design and engineering team, maybe you're talking to your clients, down the road you're talking to your vendors, everyone has a really clear idea of what you're building. Now, in terms of the bathroom grab bars and our requirements, this is definitely not an exhaustive list. There's many more, but we noted down a couple just to give you an example of what this might look like. So looking at the slide here, we've chosen to group them into ergonomic, functional, aesthetic. And one thing to note about when you're at the stage of noting down your requirements is try to be specific where possible. So, for example, under functional, we're noting that the grab bars should withstand moisture and cleaners for 10 years. So having that 10-year designation is very clear for whoever is involved in this project that this is what your target is and what you're working towards. This won't be possible all the time, and we do have some more open-ended requirements here. As you go through your development journey, you might learn things, circle back, answer them, but we are noting them down just for reference as areas to explore. Now, in terms of, for the purposes of our case study, what our research identified is that there are two big themes that we would be looking into throughout our development. One was mounting. So current grab bars are mounted, a lot of the common ones on the market are mounted through a screw-based system, which does work, but it does create some risk of damaging the substrate, the tile that you're mounting into. There are some alternatives as well, such as adhesives, clamps, suction cups, but through our research, some of which has been done right here at KITE, we discovered that those are generally not strong enough or supportive enough, and so are not really recommended. The other area was aesthetics that we identified, and for the bathroom grab bar, a lot of the bars on the market today, they're kind of that like U-shaped silver one that you saw a couple slides back. And most individuals, when they're considering putting those in their home, they feel like that's just too clinical, it doesn't fit with their aesthetic, so they're really reluctant to put those in. So those are kind of the two main themes that we'll be focusing on as we go along here today. And we'll be exploring opportunities or limitations as well for how we address those two themes. Now, before we get there, though, I did want to expand a little bit more on design research as well. For the purposes of this case study, we mainly looked top level, fairly top level. We looked at some construction standards. We consulted some online reviews. And most importantly, we spoke with Dr. Alison Novak right here at KITE for that expert insight into what are the themes that we should be focusing on. However, research, design research, it can go very broad, very deep. And there's just some of the kind of techniques out on the slide here today. We won't go through all of them, but it is something you can read more into if you'd like. The selection of your design methodology will depend a lot on what type of product you're designing, what market you're trying to enter, and also realistically how much time you'll have, because time is always a limiting factor in product design. But now, hopefully, once you've gathered all requirements, answered all your questions, done your research, you're starting to have a pretty good idea of what your product should do to be successful. And the next step that we'll move into here is concept generation. And within that phase, we take all these thoughts that we have and start bringing them to life. And as Paul and Rob will tell you, that is the fun part. So I'll hand it over to them.
Thank you. Okay, so we start with divergent thinking. In this phase, we're just letting our brains roam. We're trying not to overthink anything. We're just getting quick sketches out, rough shapes, very little notes. It's messy on purpose. The goal here isn't to find the perfect direction. It's just to see what's possible. For something like a grab bar, that might mean exploring different forms, profiles, mounting styles, even ones that might not work. It's just a way of keeping our minds open. Convergent thinking. Once we've explored a bunch of directions and we have a design worth pursuing, it's time to start narrowing things down. We choose our mounting hardware, our mounting and our hardware options, and consider the manufacturing process we might use. It's where we think about what's realistic, what's safe, and what makes most sense to the user. We always try to imagine someone experiencing the product for the first time. Do they instantly understand how to use it? Does it look good? Does it feel like it belongs in their space? Putting yourself in their shoes is the most important thing you can do, and it will help you make the correct design decisions throughout the entire development path. Okay, MVP, minimum viable product. It's best to avoid adding unnecessary features that detract from the core function and to stick with the simplest version that still does the job. By doing that, it prevents us from overbuilding, which can result in increased development and product costs, and helps us stay focused on what is most important. It's basically asking, what's the minimum someone actually needs for this product to function? Having that in mind will lead to a cleaner, more focused design, and it'll increase our potential for success. Less is more, focus on the core. Okay, CAD, or computer-aided design. Once we've refined our sketch and we know what we're aiming for, it's time to bring it into CAD. This is where the sketch becomes something with real dimensions and real constraints. We start to visualize how things fit, how they move, and even how strong these parts might be. The 3D model also gives us a better sense of overall proportions. It's with this model that we can create photorealistic renderings and animations from, which are great for presentations and attracting potential investors. The CAD phase is really the last step before making anything physical. And speaking of renderings and animations, hopefully it loads. Here is our grab bar. So even though it's not a real product yet, it's still exciting because we can really start to visualize this product existing in our world. Okay, how this aligns with our requirements and solutions. So on the aesthetic side, we went with aluminum because it is light, strong, and holds up well over time. It also gives us flexibility with finishes and colors. We went with a profile that has a smooth outer face, but with a hidden grip along the back for a clean and minimal appearance. For the mounting, after speaking with Dr. Novak, she advised us to steer clear of any double-sided adhesive or suction cup mounts, and to just go forward with a more reliable screw mount. From a functional standpoint, we considered moisture and chemical exposure so that it stays dependable and looks great for many years. And we made sure that the dimensions and strength requirements align with the recommended grab bar standards. Cost versus quality. We're always balancing cost with quality. Good design doesn't have to be expensive, it just has to be thoughtful. The goal isn't to overspend, but to invest in what truly matters, like durability and fairness, so that we get the best value without adding anything unnecessary. Okay, so at this point, we have a design that we're happy with. It's starting to feel tangible. However, it is all still theory. We are now at the point where we have to prototype it, test it, find out what works and what doesn't. This next phase is an incredibly valuable part of the development process and a fun one at that. And with that said, I will turn it over to Paul, who will walk you through that journey.
Sure. Make sure that animation works. That's good. Yeah, so part two, we'll talk about validation. So one thing to consider is that the validation process is far from linear and usually involves multiple rounds of prototyping, testing, and refinement. As Rob was talking about earlier, just now, there's no amount of 3D CAD that will fully capture how a product feels, functions, or performs. So to truly validate your design, you must build a physical prototype and put it to test. Testing prototypes is essential because it helps us study the user experience in real life and help identify design flaws early. Fixing problems down the line can be costly, so we try and repeat this cycle as often as possible till you guys feel more confident moving into production. So here's a quick breakdown of our 3 main stages that we follow for prototyping. Depending on the complexity of the product, we typically go through 2 or 3 rounds until we're happy to move forward. Mechanical products or designs with integrated electronics typically take a little bit more. So it's all about how comfortable you feel moving forward is the main point of this phase. So we'll start off with the mock-up. The main purpose of the mock-up is to quickly and inexpensively explore ideas and validate concepts before committing to your final design. Mock-ups allow us to identify issues and gain feedback early in the process with the emphasis on function, form, and ease of use. It's also important to note that no prototype is perfect, and you might also benefit from failed prototypes, identifying flaws that you might not even have discovered during the concept phase. So typically, and you'll see here in just a minute, we usually use FDM 3D printing for this phase. It's affordable and it's really useful for getting products into your hand super fast. So without further ado, I think Michelle's going to help us out here, and Helen. Here is the full-scale 3D printed model of the grab bar. Hold for applause. Yeah, so we actually also have some 3D printed sections that Rob and I tested throughout the process. So I think Michelle and Helen's going to hand those around as well. You guys can get a feel for them. So as we move into the functional prototyping stage, we can now apply the feedback what we learned from the mock-up and start refining details and mechanical functionality. Taking the grab bar as an example, we can leverage high-precision techniques such as SLA or SLS printing to better explore features such as the grip or the texture, as well as how well the parts can assemble. We can also lean on CNC machining to produce high-level parts using the same materials that we do intend to use for in production. So here's a quick image just to kind of show you the before and after of a CNC part. These processes do, however, come with a little bit higher upset cost as well. So it's something to consider during your process. Moving into our final refined prototyping stage. This involves making a near-final production-level model. This step ensures aspects such as comfort, design, and performance are all validated before you make that final leap into production. They will be built with the same materials that we plan to use, so it will look, feel, and perform like the real thing. And typically, we will use CNC machined parts for this, and in some cases, we will use rapid tooling for more complex components that can't be machined. And in many cases, from our experience, our clients will use this for marketing, Kickstarter campaigns, and presentations. So it does come with a little bit of a higher price point, but it does allow for final testing and allows you to make smarter decisions before launch. So we definitely feel like it's worth the investment. Just quickly here's an example of one of our clients' projects. He trusted the process. We went through multiple validation cycles to get to the red product there on the left. Very minor changes were made moving into production there, so that was really worth the investment for him. Oh, and we'll move into patenting with Lena. Sorry.
Thanks, Paul. So one area that goes hand in hand with new product development is patenting. And so we'll touch on a few of the top level themes here. And full disclosure, we're not patent attorneys, and we absolutely recommend working with one if you're considering patenting. But we do get a lot of questions about patents in our day-to-day, so we've kind of summarized some of the key highlights here. Another note before we jump into this slide is to note that the information here skews a little bit towards the US patenting process, and there's several reasons for this. One is that if for most new products coming to market, the US is likely going to be a big customer base for you, just purely on population size. And so if you're selling in the US, you definitely want a US patent because patents are geographically specific, so they apply to the country in which they're issued. So if you're selling in the US, you probably want a US patent. Additionally, US and Canada are both part of the Paris Patent Treaty, which means that a patent filed in one country, if you subsequently file in the second country within 1 year, your original filing date is recognized. So because of some advantages in the US process, some or a lot of people actually choose to file in the US first. But jumping into the details of the patents. So what kind of patents apply to physical products? There's kind of two main categories. One is design patents, and that simply protects the look of your product. For example, if you think of the early iPhone models, they actually had a design patent issued to them to protect the unique look of those devices. However, for most inventions or new products coming to market, you will likely be more interested in a utility patent. And a utility patent protects the how-to of a product, the how it accomplishes something. Now, if you are at a mature stage with your product development, you know exactly what your product does, what it looks like, you can likely go ahead and file a non-provisional patent, as it's known in the States, or just a regular full patent in Canada. And this begins the examination process immediately. It's definitely more expensive to get that filed. And once filed, there's very limited changes that you can make. So you better be pretty sure of what you're submitting. But here, there is where there's a bit of an interesting option available within the US system, where they have something called a provisional patent. And so provisional patent is essentially, it's like a placeholder. It gets your foot in line, but it allows you 12 months to continue refining the bits and bobs of your invention before submitting a final application. And so it allows you to use the patent pending designation, and also it is significantly less expensive to get that done. So those are the overview of the patent types. I'll also cover a few other kind of popular questions that we get on patents. Now, one common question is, when is the best time to file? And for that, based on our experience, we would say that the best time is generally once you've done a little bit of development and ideally even some prototyping. And this just allows to ensure that your claims are the most accurate and give you the best protection. Now, the other thing to chat about is what I'll describe as the oh no scenario. So let's say you have a great idea, you're excited about it, you're researching it, and then you come across a patent that looks very similar to your product, and you go, oh no. Now, the important thing to keep in mind if this happens to you is that patents are a collection of claims that protect how something is accomplished. So I'll give you a bit of a silly analogy here. Think of, imagine you're handed a cake covered in decadent chocolate icing, but you don't know what that cake is on the inside. Is it a red velvet cake, or is it a vanilla sponge cake? You just don't know. And that's kind of how you can think about patents. They might look similar, but it is the unique ingredients and combination of those ingredients on the inside, which is the claims, that give you the special protection. So even though two things might look the same from the outside, it doesn't mean necessarily that there's an infringement. So this is why it's very important to work with a patent professional, patent attorney, get them to review whatever patent you have in question, and only they can provide their professional opinion as to whether or not there's an infringement there. And now the final thing that we'll just touch on is, should you go ahead and do a patent search to begin with? And it kind of depends. If you are entering a marketplace that's very saturated, or it has a significantly high R&D costs to enter it, it could be useful. But just remember, if you are going to do one, try to do a patent search early on in your process so that there's still lots of time to make any updates as needed. So that's a top-level summary of our patents, and hopefully, once you've worked through this process, you'll have your patenting plan in place, you've done some validation through prototyping, and at this stage, this brings us to the last section, which is part 3, and in this section, we're gonna look at how to get your product through that final production step and onto the market. So let's get started. Now, the first step of taking your product to production will likely involve finding a company willing to produce your product, so manufacturer sourcing. And the production process, has lots of ups, lots of downs, so it's really important to find a manufacturing partner that is a good fit for you, they're reliable, you feel comfortable with them. Basically, be thorough in the search. In terms of how does one find a manufacturer, there's kind of common ways are just to do the basic web search, consult business directories, all valid approaches to finding a manufacturer. But there is one additional approach that not everyone is aware of, and that is working with a sourcing partner. And so a sourcing partner is kind of like a company who specializes in matching individuals looking to produce something with vendors, kind of like a matchmaker. And from our experience, it is actually quite advantageous working with a sourcing partner. They just have so much deeper knowledge into the network. They can do the business checks for you, the financial checks. They can even help with quality assistance or quality assurance. So you're really ensuring that you get the best possible fit for your product to take it to production. However, before you land on your manufacturing partner, there is some questions for you to consider and some homework for you to do as well. Now, the things that you should be considering as you get into the journey of looking for your partner is, first of all, what is your first order quantity? So are you going to produce 1,000 pieces or are you going to produce 10,000 pieces? And this will affect everything from cost to the timeline and also just a range of vendors that you have available to you, because some of the bigger vendors, they won't necessarily be as open to working with these initial products, opening market items. So it just helps you narrow in on a range that you're comfortable with. The other question that's becoming more prevalent in this day is, are you interested in domestic manufacture or overseas manufacture? From our experience, currently, it is still more cost-effective to manufacture abroad, but that's the environment's changing, so in 5-10 years, it might be a completely different answer. And lastly, the thing that you want to consider as you're looking for a manufacturing partner is, what scope of services do you want them to do for you? Do you want them to be a one-stop shop where they do the production, they package it, they export it, or will you be working with multiple vendors along that entire chain? And so once you've got your, hopefully, partner lined up, you're comfortable with them, excited, what's next step? Are you ready to have the product getting off the production line? Well, not quite. There's one more important step to come, and Paul will be able to tell you a little bit more about that one.
So it's important to know that creating a product just isn't about how it looks or functions. We also need to consider how cost effective it is to scale up. So that's where DFM, or Design for Manufacturing, comes into play. In our design of the grab bar, we've applied DFM principles to bridge the gap between concept and production. This is something we always do early on during the conceptual phase to make sure there's no surprises when we reach manufacturing. So a quick breakdown here of the core principles. It's always important to simplify your design, to have fewer components and assembly steps to reduce failure risk and keep your costs down. The same principles also apply to your packaging as well. From experience, we have a lot of clients who want fancy packaging, which will end up being more expensive than the product itself. So more complexity equals more cost and slower assembly. So we always suggest to keep it as simple as possible. Using standard off-the-shelf hardware will reduce the number of custom tools needed in your design. And it's also beneficial, where possible, if you can use symmetrical parts. That will simplify the molding, and it'll also minimize your assembly mistakes as well. So just kind of some rules of thumb when you reach that stage. And it's also to help lower the risk of defects when you're in production. We also focus on using common production materials and processes. So here's a quick overview of the grab bar, kind of giving a breakdown of the components that we've used, common manufacturing processes, symmetrical parts. We've got the same end cap that's in both ends. The screw cap is the same part as well. So something we've considered during the concept phase to get to DFM. So we can actually take a deeper dive into a couple of these examples. So as I just mentioned, by making the end cap fit both ends of the bar, we've simplified the assembly and reduced the number of parts we need to make a mold for. So that's big cost savings there. Once we then choose the best manufacturing method, we'll hop back into CAD and we'll start optimizing the design to make the mold. In our case, the end cap would be modified to meet die casting requirements. At this point, we're usually working with a vendor by now, so we'd start to apply DFM best practices. In this case, for the end cap, we've added draft angles and we've reduced wall thickness to improve the moldability and minimize the part weight. So minimizing part weight on one piece might seem minor, but that weight reduction becomes substantial when it's scaled for mass production. So it's also something to consider. And now at the start of the show, the grab bar itself, the process for this is pretty much a no-brainer. Extrusion dies are the go-to process for manufacturing long, uniform shapes, compared to other processes such as machining, injection molding, die casting. It's a lot more cost-effective and produces a lot less waste as well. So, and similar to the end cap, the bar can be engineered to perform at a lighter weight and with thinner walls. So here's a quick kind of side-by-side comparison. Looking at the end cap, the one on the left is the prototyping piece that's been handed around, and that's kind of how it would look come production. The bar doesn't look too different, but you can see on the far right it is 2 mils uniform wall compared to a little bit thicker for the prototyping part. So yeah, so now that's kind of your overview of the DFM. We can now look into more production costing, and Lena's going to take you through that. Thank you.
Thanks, Paul. So once you've worked through your DFM and secured your vendor, at some point you will likely be given a quote that details the cost associated with producing your goods. And the costs here are more for illustrative purposes. They're not actual costs that we went out and got from a vendor, but we did want to walk through an example of what some of this might look like. So let's dive in. One section of the quote and the costing that you'll get will be the unit cost. So that is the cumulative cost of all the components and materials, et cetera, required to make one copy of your product. Then additionally, once your product is made, it will need to be packaged, shipped, warehoused, distributed, marketed, et cetera. There's quite a few other things going on around products that you'll need to account for as part of your kind of costing plan. So that's there as well. And then the other section that will make up a sizable section of consideration is the tools and molding. So in order to make parts in kind of the modern day world, no one's sitting there carving out your tea kettle for you. The parts of your products will need to be made through machines, and so those machines and tools essentially need to be made themselves. For example, for our grab bar, the main length of it is the extrusion piece, as Paul mentioned, so there'll need to be an extrusion die made to make that extrusion. Additionally, if you can think of all the plastic products on the market today, all those plastic pieces are made through a process called injection molding, or typically, that's a very common process. And so injection molding tools also need to be made and are quite sizable and expensive usually. And that is a thing to note. Tooling and molding will usually be a fairly sizable chunk of your initial financial investment for any product you make, but it is an upfront cost that you kind of pay once, but then your tool will be good for many, many rounds of production runs. So you can amortize that cost over many units or many years. And so looking at kind of where we ended up with our costing here, you can see taking the unit costs into account, the additionals, and then the tooling and the molds, you end up with a total of around 10K. So how you want to slice and dice that for your individual unit cost will depend on your individual business plan. But I guess the key thing to note here is that what you start with as a unit cost will likely not be what you actually sell your product for by the time it gets to the consumer. And so a common question is, well, how much should I sell my product for? And from our experience, for kind of the average consumer goods on the market today, that ratio is about 3 to 4. So 3 to 4 times the unit cost is what you'd probably want to be selling your product at. And this is just, average for kind of the most common goods. For products in the medical field or some like luxury goods, that ratio is probably quite different. But 3 to 4 for the average consumer good. So that's kind of the summary of costing, and that does actually bring us to the end of our product development journey today. And what a journey it has been. We've looked at how to gather requirements, how to generate some solid concepts, how to validate them through prototyping, and then what are the considerations for getting through production and out to the market. And so it's definitely not an easy journey, lots of ups and downs, and of course in the real world it takes a little bit longer than the length of our talk here today. But the important thing to remember is that it is very much possible with the right approach for your product, your idea, to make it out there to the market and make some really positive, impactful change. And that is our hope for many of the great ideas and innovations coming from Kite today. And of course, as for us, we hope we've been able to provide some useful insight for the development journey today. And if you have any other questions or want to learn more, don't hesitate to get in touch. Thank you so much.
It's our cue. All right. Thank you, Lena, Paul, Rob. What a task that we gave you, right? So for a lay consumer seems like such a simple or basic product, the amount of thought and consideration, behind the scenes work that goes into. I hope this gives you appreciation. I know most of us are in the design field of just how much work, right, and how much due diligence and how much creative thought and engineering smarts goes into the simplest of products. So we are going to immediately actually go into that phase where there's an opportunity for folks to ask questions. I'm going to warm us up because I see one come through our Menti, which I will just amplify again, menti.com, or right here. We'll take, actually no, if we can go back a slide just so folks have the Menti code up. And the question that came through is, can the panel speak to considerations around universal design in product development? And because I now spied Dr. Novak, Iris, a whole contingent, sorry to put you in the spot, friends, of researchers, scientists, product developers that represent various Kite teams, I'm going to add a layer to that and call out accessibility or aging populations or other kind of very specific user groups to that. So I think it was mentioned maybe in passing, if you or anybody actually in the room here representing Kite that has a perspective on that wants to comment on universal design and incorporating that into the design process. The floor is yours.
Good question. Sorry, what was the question again?
Around, speak to universal design, and I'm going to add accessibility, right, as a design objective in the product development process and cycle.
On that one.
Yeah, I don't really know where to start out. I guess for universal design it would be what's widely accepted for most people. So not trying to do anything too much out of the box that might throw people in a wrong direction. But I guess universal is a very ambiguous. I mean, age-wise or.
Yeah, maybe that's the natural place to bring in some of our team. And doesn't have to overhype Kite, but even if you see in the back, you could see some of the work that we do establishing design standards or accessibility standards. So curious how the science that goes into that translates over to a product development world. I don't know if anyone on our team, maybe Dr. Novak wants to comment on that.
Yeah. Thanks,
Hi,
Alison.
I'm Allison Novak. I'm a senior scientist here. I like your hesitation because I also not sure about the term universal design as a concept. I think we strive for it. I think it's very difficult to achieve. What was the question? Sure. So like when you think about products, I guess it depends on the product and who the intended users are. Ultimately, like a grab bar can be used across ages, across ability types, and so I think I liked one of your slides. You talked about, I don't know if it was the journey, and you talked about expert interviews and et cetera, like the mapping, and then the prototype testing in that cycle. And I think it's through those pieces is when you can really gather information from the end user as to whether this will suit their needs. And whether it's through focus groups or through usability testing, or I don't know how you do it in industry, but that's how we would do it in research. We would bring individuals in and do usability testing, or do maybe some qualitative analyses, some user focus groups, or various methods to gather feedback on the intervention itself. And so, and then I think when it comes to universal design or creating something that meets the needs of most users, then you consider what users you're targeting. Does that?
Excellent.
Yeah, your answer.
Thanks, Allison. We're getting some juicy ones
Thanks,
here. I will,
Allison.
again, amplify that for my personal health and wellness. Ask some questions to the floor so I can run this mic across the room, get my steps up. But we have a couple fun ones. So here's another on Menti that says, that asks, how has AI tools, or how have AI tools affected the process of industrial design? What would be the future of industrial design adopting new technologies primarily in the design process?
Sure, I can speak a little bit to that. So obviously, we have seen AI become quite popular in the last year or two. From what we're seeing right now is, I would say, it's more helpful towards the later stage of the development process. So obviously, with creating amazing renderings, and if you're sourcing that one little bit of hardware that you're not quite sure where it is, you can kind of, input it into your Copilot or whatever, and it'll do the search for you. So it's kind of really helpful towards that latter stage of development. But it still struggles in the earlier stages. So really, it doesn't have like the ability to connect the dots. So, we talked about how the grab bar is an aesthetic. It needs to have an aesthetic quality, like it needs to fit within people's personal homes. And so it can generate some concepts, but they don't always match what we know rationally as humans that people want. So give you crazy shapes or like crazy colors that don't make sense. So it's still kind of struggling on mapping the requirements to the truly useful outcomes of the product. It's also still not quite there in terms of generating like useful 3D. So at this stage, you still need an engineer or a designer to tackle that. So I think that's kind of where it's at currently, but we are, as excited as everyone else to see where it will go in the next couple of years.
That was perfect,
Did I
yeah.
spy a question on this side? Is there, is it?
Earlier, I was going to make a comment about the guidelines for disability. Sometimes when you were talking about universal design, there's the guidelines that you check for the codes. Then the codes also have, dimensions that you can follow in terms of, which, if people have arthritis or whatever problem, and like what are the sizes, like the right fits to go for when you're designing something. So I'm sure they take those into account when designing the products. When you call universal design, there's researchers that come together with certain guidelines in terms of sizes and dimensions to follow to do the best you can do with your creativity that it suits most people.
Thanks. Perfect.
Thank you for that. Another question here. I'm not sure if this is referring to 3D printing for like just the prototyping or for an end product, but the question is around wanting to know more details regarding production speed and efficiency of 3D printing a bar like this?
Yeah, so there are different types of 3D printing available. The process that we use for these prototypes is FDM. But generally speaking, 3D printing is quite rapid. Like I think this prototype here was printed, I don't know, maybe
Few hours.
6 hours?
6 hours? Yeah.
Maybe like 6 hours, all the pieces for the full length one. So it is quite rapid. There are also technologies with more advanced printers now that take maybe a little bit longer, but they're able to produce higher quality outputs, so almost anyway, almost competing with production level like tooling and molds. So that is becoming kind of an avenue that you can pursue instead of investing into very expensive tooling, as we talked earlier. You can, for short runs, you can almost use these 3D printing processes. So.
This was great to see the process itself. We have a question around what is the realistic timeline, start to finish, of bringing a design like
That's
this
a
to
good
market?
question. I can go. This from our process. Again, it comes down to the level of complexity. So, say we can actually use the one on one of the slides as an example. The concept phase that Bob was talking about was probably around 4 months to get your idea. Okay, this is how I want it to look, how I want it to function. For that one, can we go back to that slide just to make it a little bit easier to talk about?
From the very beginning?
No, it was the refined prototype phase. Beard tool. Oh yeah, that one.
Wait.
No, the one with the beard tool.
Yeah.
That one, yeah. So the top right, that was probably around a 6-month project to get to that stage. We learned a lot from that product, and we were able to move into the more refined one. So, sorry, back to your question. About 4 or 5 months for the functional prototype, and very minor CAD changes were required to get into the refined, and it was really just fabrication time. So probably around 2 or 3 months for that part. So I'd say, yeah. And then production itself, one of our agents usually says it's like having a baby. So it's probably like a 9-month phase from sourcing your manufacturer, having tooling made, having it shipped out to your consumer. So you're looking at like 2 years from start to finish, if it's simple.
Takes a lot longer than people think.
Yeah, yeah. And this isn't the most simple design to showcase, but this kind of shows you how long that would take.
All right, see a question from the floor here.
So I guess my question is on the area of influence. I don't know if you can go back to the slide. The area of influence. I think you talked about area of influence where you talk about user needs, regulatory concerns. So I guess I have 2 questions. So would you say any of the areas carries like more importance than one? And how do you deal with how do you navigate situations where maybe during whatever stages where something changes, maybe like the user needs, maybe there's some regulatory whatever that could maybe kill or break your product. How do you navigate that? And at what points do you always go back to your area of influence to kind of I don't know, refine or just adjust your product ideation or creation?
Yep, that's a great question. So one of the bigger areas will likely still be user-driven, so like those user needs that we talked about first. Ultimately, the user is the one who's going to be using your product, so if they don't like it, nothing else really matters. So I'd say that's still the biggest influence. Environment is important, and then it kind of relatively decreases in importance. You still have to consider it. So for ours, we kind of mentioned about where is it distributed and also any regulatory considerations. In terms of what happens if things change halfway through. And the reality is it's actually very common for things to change as you go along. And this is kind of why we structure our development process from being kind of rough, progressively more refined, because if you do an initial mock prototype, quick 3D print, and you learn something, it's much easier to go back and make changes and adapt before you continue forward. So you're kind of going from very rough to more refined to more refined. And that just helps that hopefully by the time you are in the very refined stage, you're not really getting any curveballs. Like you've kind of flushed out all the issues that might come up, and your product's just really solid. But again, it's just a matter of iterating, testing, iterating. That's really what it comes down to. Does that answer it? Okay.
All right. Next question here, and then we're going to hop to the other side.
Firstly, thank you so much for the presentation. It was really interesting and engaging. My question is related to how do you find that sweet spot between cost and quality? Because like often, like even if you go behind cost, the quality might reduce as well. For example, even the grab bar, like I'm imagining maybe even the end caps can be made with plastic. It can reduce the weight, it can reduce the manufacturing process and cost and everything. So what are the factors that affect that?
Well, I think that's a good question. I think we always try to push the design that we're happy with through the pipeline until we get to production. And then if we get a quote back and they're highlighting certain components that are more than we were expecting cost-wise, yeah, we can look at alternative materials that won't sacrifice the look and feel. But yeah, that's definitely a fine balance of finding where can we make those compromises without discouraging the end user. But yeah, that takes time. That balance.
I think I might also just add a little bit note to that as well, is that kind of costing is an important question to ask early on as well, even as you're just doing the initial requirements gathering, because it can drive a lot of the design choices. So that's, when you're starting on your development journey, already identify like what is your customer willing to pay for this product, and that can kind of help filter down into some of the design decisions that will hopefully, once the product does make it to market, it kind of lands at that right sweet spot.
I have a few questions. So let's say you want to have a user-centered design, and maybe you're not 100% sure on your user needs. In your validation, do you run focus groups or have the users actually tested as well? Is that a common methodology used?
Yeah, that's typically, like in our line of work, we most of our clients are the experts, so thankfully they feed us all the information. In most cases, as much research as you can do, the better. You really want, like I said, you want to put yourself in the end user's shoes as much as you can, so that if that requires case studies or speaking with people in that market, then that's the best thing you can do. You want to add anything to that?
No, that's good.
Well, yeah.
I think that's why it's important, the very initial mock-up prototypes. You learn so much from those. For example, the grab bar, the main feature was obviously how it feels, right? So that's what we printed off those small sections. That kind of helped determine the rest of the design as well. Yeah. So very step by step.
You would give those to your clients to go do focus group.
That'd be built into the, exactly.
Okay. And at what stage do you really seriously start thinking about design for manufacturing? Is that from the first thing?
Early on.
Very early, as early as possible. Yeah. I think we kind of, with simple designs like the grab bar, we kind of already knew, okay, we know how this is going to be made. So we focused on keeping it in line with that. So there was no surprises when we're working for DFM. It's already kind of aligned. Like the prototype is very close to what it would look like in its final form. So something we always keep in the back of our minds. We won't design stuff where we know it can't be made, essentially.
And last question is that in your cost per unit, I'm wondering why didn't you consider the R&D cost as well?
That is definitely a consideration. I guess the way we kind of look at costing is from a production perspective, like what are the numbers that you'll be given as you're looking to go into that production process. But obviously, as part of the bigger business plan and as part of the bigger product development process, as the person kind of owning that development, you will have to consider the R&D cost as well. So that will be factored into it, but as well as we mentioned, that kind of ratio of your unit cost to the final cost that you set the product to be costed at for the consumer, there's always a ratio there. So if there's significant R&D that went into it, you might want to increase that ratio to get back some of the R&D investments that you made early on.
There was a question, I don't know if it was yours, that was getting into the accounting, right, of recovering initial R&D costs and how that's reflected in the balance sheet, among other things. I don't know if there are folks in the audience that had direct experience with that as well, or even us. Like I know, Iris has a question. I don't know if it's an answer there or it's a separate question, but it is a consideration. I'm curious even amongst us, right? We're not a traditional product developer, but a lot of the research and science that we do here organically, right, produces prototypes, hints at solutions. It's a different accounting, right? When a lot of the original science that went into that was maybe not even product development. So it's not really a question or an answer. It's more of like a point of curiosity as to how our world kind of interfaces with yours. But Iris has a question.
Okay, so as a grab bar researcher of many years, and as someone who's watched a lot of people grab onto grab bars and see what they do, a lot of times when you get to the end of the study, it's just kind of like a throwaway thought for us of making recommendations as to what should change in terms of products that are available. And I see in your product that you've prototyped, for example, I would have put some crosswise interdigitations and not just longitudinal. I would have made it like the same depth and width. So how could we have communicated that better in our research findings so that it's interpretable to you for your design brief?
Very good question. And this is a conversation. Like this is a genuine, right? I think opportunity for us to kind of connect our design processes. So.
Yeah,
reactions?
That's a great question. Yeah, we did consider the vertical applications, and given that it is extruded, we're limited to that same axis of flow, unfortunately. That's why we made those alternative profiles, because we thought maybe the meat of your hand could go through those gaps and create some friction there. And that's where we prototype and test that out. But if we can land on a profile that does work in both applications, then that's fantastic.
A loosely related question in Menti. What users might say they want or think they want may be very different from what they actually want or need. What tools can be used to uncover real needs and desires that are meaningful, right? So, I mean, Iris has direct experience on the testing side, which we can all imagine, especially when you're trying to get to like a medical or clinical or answer a medical or clinical hypothesis. Not the most accessible, right? Very expensive process. So what are other processes that folks can leverage to really zero in on the real user wants and needs?
I can kind of speak to this one a bit, but I think for us, what we've seen is once you get to that prototyping stage, that is really where it kind of meets of the thing that you think you want and the thing that you actually want, because when you're starting out and you have all these ideas, kind of like even the comic that we had at the beginning, you have all these ideas of how it can be, but then once you actually prototype it and hand it to the user and they interact with it, you're like, oh, I actually don't need all these other things and they're just impeding my use of it. So for us, we find that's an intersection where a lot of the unnecessary things fall away. And again, as Rob touched on the minimal viable product, keeping it simple, it helps streamline the development timeline, reduces costs, so it's really just great to keep it as minimal as possible and focus on the core value. And in prototyping, that usually, for us, that's where it really comes to the forefront. Not sure if, did Alice?
Well, I kind of have a question, I guess. I'll follow up on my colleague Iris's comment. We do our own research, and communicating our research findings to you is critical, but similarly, if you produce a product, bringing those end users in to test the product is really critical to its usability. And so I'm curious, in industry, how you partner with research to do that, or if it's not beneficial to partner with research institutes, how do you get those critical end users, i.e. the patients who are using, like I'm thinking assisted devices rehab space, where you need patient populations to test your product to establish its usability. Because a grab bar in my hand is quite different than a grab bar in an arthritic hand, for example.
So for us, within our process, what we also see is that once you go even to production, that first production run, we recommend that it's very small. Maybe it's 500 units or 1,000 units, and essentially it is kind of like that proof of concept stage. So you are getting it out to the people that need to use it, and but you are getting it out to a larger population. So the feedback you get back is more quantifiable and wider reaching, and can be, again, iterated into the next version, and then applied to improve it.
So how do you get that feedback?
So I think that is just getting it out there. I think producing the product and
Like reviews online, like how do you actually get that feedback?
yes, actually, yeah, reviews online are great. You can still do focus groups. I think some of the clients that we work with, they do arrange focus groups on their end, so that is definitely an option.
And I think in a sorry.
Just so the folks
Thank
know.
you. Yeah. I think in a rehab space, it speaks to one of the questions that was previous. People don't know what they need, oftentimes. And so people think, oh, this is comfortable, or this looks good, or I don't want a really long grab bar. They don't know what they actually need, and so the review online might not synchronize with the actual needs to support, if it's an assistive device, to support that user, for example.
Yeah, I think I would say, again, this kind of, the method of research that you select will depend a little bit on your product type, and it does sound like in this setting, focus groups might generate the best input, and that is totally fine, and that would be a great tool to use, but it really depends on the type of product and how it's handled by the users that will dictate how you approach the research. So it's a little bit of a push and pull there.
I think question here, and then
Yes, so I'm not sure if you have experienced this, but there are times where, like, even if you have tested a product, you kind of come to know there's like a design defect or a manufacturing defect after like a year or two of prolonged use. So are there, like, how do you kind of manage that? Like, is there any process, or like, how do you have like someone like looking out for their product and seeing how it is, happening, like how it's doing well or not in the market, and how that is, the process of that?
I mean, this is more, as I guess we could speak on behalf of the clients that we work with, and just some of the things we hear back, since we ourselves don't necessarily put product to market. But I think from what the feedback that we get is, usually once a product is out there, you'll see, based kind of like the sales, and again, the user reviews online, you'll know how it's tracking. And it is very common, as I mentioned, that first production run, it's almost like a very, very, very refined prototype. It's still in that validation stage, and it's very common after your first production run to go back and make those little updates for a Gen 2. But hopefully because of all the prototyping and validating it beforehand, it's fairly minor what you discover, and then it's easily made into an update for the next generation. And even today you see this very commonly with products. They'll come up with a Gen 1, and then a couple years later there'll be a Gen 2, and it fixes some of the issues that come out from a broader audience that uses it.
We are the guinea pigs.
Yeah.
So a bit of a time check. We do want to preserve some time for networking. I think our friends are able to stay, so if we can't unfortunately squeeze every question in, please stick around, try to track down our friends from TriMech. Let's get a couple more questions in, starting with mine, because I'm holding the mic, I can get here. So I mentioned some of our research teams that kind of, sometimes intentionally, sometimes inadvertently become product design teams. Right, because their research leads to an insight, that insight translates into a product. Through KiteRace, we have a form of our own early stage incubator, right, accelerator, where a number of our ventures have a product kind of based solution, and it always kind of, you observe the similar pattern. Everyone's trying to learn everything themselves, right? Whether it's budget, whether it's just the ambition, excitement for the solution. What are the markers? And I know it's not universally like time stamp at 30 days, at 1 year, but what are the kind of like stages or markers that you should be observing before, say, reaching out, right, to a design agency, or or building out your design team? Like, could you give some parameters that, like, when might you keep doing it alone versus advantages or disadvantages of starting to outsource some of that at different stages? I don't know if my question was clear.
Probably the cost of software.
Yeah.
Yeah, like
Yeah.
CAD software is thousands of dollars. It's very expensive, and like there are programs that you can jump into that are affordable or even free. You can get kind of a rough thing started, but yeah, I mean, I encourage everyone to try to get their designs as far along as possible. It's you're only saving yourself money, and if you can prototype, I mean, 3D printers are hundreds of dollars now. You can buy them on Amazon. When I started, they were thousands of dollars, and so I think, yeah, if people can do all that stuff on their own as much as possible, even before talking to a company like us, that'll help us out, because that means that they've done a lot more testing on their end, and it just makes that process a lot more seamless. Yeah, you will definitely hit a wall where you need to get some engineers on board and designers that can help polish that product and make it sellable.
I know that's an honest response, because you're basically saying, hold off from hiring them. Did you have one more question? Okay, you answered it. Okay, well, bring us home. Let's call this our second last, because I see our dear friend Haley. Haley, you get the last word on this one. So, second last question from the floor.
I think you mentioned earlier that no prototype is perfect, right? So my question is, so who defines this perfection, or should I say imperfection? Is he, would you say, from testing with users, and what percentage of imperfection would you say is negligible, or okay, this is satisfied maybe 98%, let's just push to market or production?
Yeah, good question. I guess we can just keep using the crab bar as an example. We, through Verify and refinement and testing, we'll kind of know how well it works, just how it feels, and then it's like, okay, for the bar, for example, we know that, it's a very simple example, we know it's too thick for the manufacturing process that we plan to use, so we can almost jump into CAD, refine it for the manufacturing process, we know it works and looks well. We can also apply like simulation and stress test on that too to make sure it's going to work with the material that we plan to use in production. So that's kind of like a very basic example of, we'll verify that until it's good to go. And we can also hop into more refined processes. Like I mentioned CNC machining earlier on. We can refine it to it looks exactly how it's going to be when it comes out of the mold. So that's like your final test. You're at that point, you're 90+% sure it's going to be good when it comes out of the mold. So. Yeah, it's just honestly just prototyping until you're like, okay, I feel safe doing this now. Like from our experience, we've had clients who come to us with a sketch, or they come to us with a prototype thinking it's ready to go. It's like, no, you've got a lot of work to do. That part can't be made. You need to do this to this piece. And we just go through that cycle until we're all like, okay, I think we're ready to move forward. So, yeah. Yeah, exactly. It's a gut feeling as well. You'll know when you're ready. And we're very honest and transparent with our clients. If we don't feel comfortable moving forward, like we'll tell them that. Because it's going to save you so many headaches down the line, and cost. If you make tooling for a product but you're not 100% sure with, it's a lot more expensive to fix a tool than it is just to re-prototype something that you've tweaked. So yeah, there's things like that to consider.
Hi, I just have a question about like small companies or startups. You talked about order quantities of being small, between 500 and 1,000 units, but like for a lot of people, they don't have the capital to invest in those kind of quantities. Like, how would you change your process, or what advice would you have when dealing with a startup company who is making something kind of interesting and maybe revolutionary or new to the market, who just doesn't have that capital to invest in large quantities?
Yeah, it is a tough situation, because as you're moving into production, oftentimes vendors will have a minimum order quantity, and so it's just kind of, for them, the cost of doing business is they have to have a certain number of units as an order. So it is a bit of a tricky situation. Usually that number of 500 to 1,000 is around the minimum order quantity that they might accept. But that being said, as a small company starting out, a good place or a good move is to use those refined prototypes that you end up with to get your word out there and start bringing investment in. So either through crowdfunding or through angel investors, whatever means you have available, like leverage that and get that initial base funding. And then hopefully that will turn around into much larger orders down the road. So it's kind of the best option that exists at the moment.
I know we haven't made it through all of our mentees, but I do unfortunately have to bring a close to the Q&A just so we have time to kind of connect and mingle as a group. So on behalf of the audience and Kite, another big round of applause for our friends from TriMet. I will plug that if you enjoyed this event, our next event, Kite Creates event, is just around the corner, November 26th. All event information is at kite-creates.ca. It's part 2 of a deep dive in Science of Textiles series that we're going to zoom really into fabric structures. So if that kind of tickles your fancy, please register online. Again, free and open to all communities. So we hope to see you there. Also want to thank again, if Dr. Novak, and I see Iris is still here, for your contributions to this. Thanks for playing along, right? Participating in this, very, I think, hands-on and lively way of delivering information. So I personally really enjoyed how just hands-on and real it was, down to, hey, come get your photo selfie in front of our graph art, but don't touch it because it's not structurally sound and all that good stuff. So yeah, let's formally bring this to a close. Thanks to our friends online for joining us, and we'll see you next week at our next Kite Creates event.
Thank you, guys. Appreciate it.
Good job.
Does the